Active remote sensors. Nature has always inspired humans. We can find several examples of plants and animals that interpret reality in other ways from humans. In other words, they have other senses, allowing them to perceive what we cannot, such as infrared vision or night vision. Some bat species have an active system to keep them upright while flying by producing a sound wave and measuring its reflection back from an object. The bat can measure the echo to find out how far away this object is and in what direction it might be. This is exactly how active remote sensors work.
If the sky is cloudy, passive optical sensors cannot see the surface of the Earth. In this situation, we can use active sensors that produce their own electromagnetic energy in the form of pulses of radio or light. When the sensors receive the echo of a signal reflected from a surface or the atmosphere, they measure its properties and extract from them very helpful information. We use two types of active remote sensors, called radar and LiDAR. Radar uses radio waves, and LiDAR uses light waves.
By analysing the received echoes, active sensors can measure a variety of physical variables. Angular resolution. An antenna is like a telescope, but it works at radio frequencies. The larger the telescope mirror, the smaller the field of view it has. Therefore, a remote sensor will only measure objects that are within its field of view, the beam of the antenna. We can improve this resolution with mobile antennas and complex signal processing. For example, the so-called synthetic aperture radar, SAR. Distance. Measuring the time delay between when a radar or LiDAR emits a pulse and when its echo is received. We can measure the distance to an object. The rule is simple. The further the pulse travels, the longer it takes the echo to return. Speed. Measuring the so-called Doppler effect that makes the sound from a vehicle sound higher as it approaches and lower as it leaves, we can measure the speed of an object. With active remote sensors, we acquire high-resolution measurements of a variety of Earth phenomena. However, to measure an echo is not as easy as it seems, because there are many factors that can disturb or change the path of electromagnetic energy. In a basic way, we can talk about how different surfaces modify the way electromagnetic energy is reflected, also known as scattering. Flat terrain like roads or water provides a smooth surface reflection, similar to a mirror. Plowed fields or vegetation provides a rough surface reflection that scatters the energy diffusely in many directions. Finally, when the electromagnetic energy hits more than one surface, such as trees or buildings, this is called the multiple bounce effect. As you can see, each of these situations results in reflections of different strengths or angles, allowing the sensor to determine what kind of surface reflected the original energy.